for today. I think it's a cute one. I hope so. You guys will let me know when we distribute it. That will be by the end of the call, and it is all done in here in our Discord server. Very easy process. Another minute for everyone to join and to go live. Let's see. Oh, amazing. It looks like we are live on Twitter and YouTube. So hello everyone. Thanks for joining today's Dev Deep Dives. We have Raymond presenting for us, and today's subject is the future is multi-chain and cross-chain. It seems like a very interesting one for me. I had mentioned previously we have a POAP for today that will be distributed by the end of the call. And if you're watching on Twitter, you need to come over to our Discord server to claim the POAP. But I will share more details and instructions on how to do that by the time it is available to be claimed. So hang in there, and looks like we're ready to get started. I'll pass it on to you, Raymond.
Sure. Thank you so much, Chibi. So welcome back. Once in a while, we try to showcase some of the research we're doing internally based upon the use cases we have. And recently, this multi-chain, cross-chain story, it becomes very interesting and very exciting. That's why I'm going to give some insights about some of the research we have done and explore some directions moving forward from here. Right. So first of all, I would claim Cloudland has been supporting multiple chains from the beginning, especially from the token gating perspective. First of all, we support many different EVM compatible chains. The Ethereum mainnet, Polygon, Arbitrum, Optimism, and Rolling, Avalanche, Eloia, a lot of other EVM compatible chains. And we also support non-EVM compatible chains. We support Bitcoin, we support Solana, we support Flow, Near, Tezos, PocketDAI. So really, if you are a member of the Cloudland tokenized community, you have already, in the world of multi-chain support. Of course, with the multiple chains, then you probably have to deal with multiple wallets on the different chains. So some wallets are compatible across chains, such as the EVM wallet, EOA wallet, but some wallets are not really compatible. The two different crypto curves are popular in the blockchain space. One is the ECDSA, the other one is ED25559. You probably only see the different wallet provider give that different wallet UI, so you can connect your browser extension or the mobile wallet or different things. That's a little bit opening statement. Cloudland has been supporting multiple chains for token gating purpose. It's we verify wallets from each of you, and we make sure the community give us that guidance. What are the digital assets on the different chains they want to use as a governance token? And we are kind of the middleman to marry that up and make the membership enforcement for you. So that's already multi-chain support. And even speaking for our own journey, say when we launched the Cloudland token, we already have the multi-chain support in mind, and also make it possible to have the token to go across chain. So when we deploy the smart contract for Cloudland token during the launch, the token was initially deployed to Ethereum mainnet. So that's really the social truth. Then we meet the supply and we immediately bridge the supply from the Ethereum mainnet to Optimism, because these different blockchain networks have a different nature, right? So mainnet is meant to be the security layer, the settlement layer. For L2s, you pay much less gas fee and you get a scalability. Since the Carbon token launch is a sponsored token launch, so it makes sense to have a L2 to pay the gas instead of like paying $30 mainnet for every single transaction. Then over time, the story continued to evolve. For example, recently we promote some of the Carbon tokens on the Option network, right? Then for some users, you sort of have to bridge the Option token back to the mainnet. Then you find a way into the Option blockchain. Then, of course, physically, logically, it's the same token, but physically they do have presence on the different chains. So that's another example of this multi-chain, cross-chain support. Okay. Then we launched Terafans. So the initial launch of Terafans, we pretty much write on Arbitrum. And of course, we introduced this concept of smart cards. So it's a contract-based wallet on the Arbitrum blockchain. So that means like for Terafans, we start with Option and then deploy the smart contract for the users, right? And the one demand for the Terafans itself is say, hey, how we can expand to other chains. So we don't have to be locked into one chain. We want to get the same utility, the same platform for multiple chains. So that's another realistic requirement for us as well. Then kind of stepping back a little bit. So I think most of us has been in the crypto space for some time. Some are relevant news, some are savvy. But I think we often see the struggles the user have to come on board with crypto Web3. So number one is onboarding, right? So imagine like for your browser extension, how many wallets you have. And also considering on your iPhone, on your Android, how many mobile wallets you have installed. So that's such a headache to manage so many accounts, understanding there's so many different security concerns, memorizing the private keys, the seed phrases, and use a different UI to connect to the different wallet. And often, sometimes we're still making mistakes, right? And we might use the wrong wallet to the wrong network. And second one is like for any, transaction to happen on the blockchain, you need to have a signing process. So signing process is adding a stamp to the transaction so that the blockchain can independently verify that's just the transaction coming from the sender, right? And there are different schemes to sign. Some EOA wallet can produce a signature directly, but with the smart card, it opens the door for other authentication schemes such as a passkey, even JWT, or zero knowledge proof. Okay. Number three is you have to pay the gas fee. And how do you pay the gas fee? You need to acquire the native tokens on each blockchain network, right? So if you transact on Ethereum mainnet, you have to use the mainnet E. If you do that on Solana, you have to use the Solana token. If you have to do that on NEAR, you have to use the NEAR token. And even though sometimes you do have E on the Ethereum mainnet, and I want to buy a meme token on Base, then I have to bridge my token from mainnet to Base, and I have to pay $20-$30 to do the bridging. Right? This is such a headache for new users as well. Then looking at this decomposition or decoupling of the different responsibilities when you try to do anything on the blockchain, right? So it's very much, first of all, the user need to tell the system what they want to do, right? And oftentimes we can call that as a user intent. For example, I can buy USDC with my E on Polygon. I want to swap my USDC for Climate tokens on OP, right? And that's a non-technical term, like the user can say what they want to do. then this intent can be translated into different so-called like a transaction request. So transaction request is a structure, usually say, hey, which smart contract you need to interact with, what's the value of that transaction. Then even more exhaustive is like you have this so-called call data. Technically, it's kind of just encode the transaction, interaction with the smart contract. Typically, that will involve the method name of the function and also the arguments you have to pass in. Right? Now you build this 0x transaction. That before you can send the transaction for any blockchain to access, you have to sign that, right? And also you have to figure out how to pay the gas fee. Then once you have the transaction arrive in the blockchain will do validation, and if everything's good, then they will execute it. So your state will be persistent on the blockchain. So that kind of closes the loop. So what's interesting is like there are different solutions for that. And I think the slideshow actually missed one thing I had in the past. Oh, okay. Let me open a different diagram that we want to show some of the challenges we have. Give me 1 second before I jump into some of the solutions. So I create a multi-chain diagram. Okay. So this is such a busy diagram, even from the token gating perspective, right? So here's the user, the pool user, right? Then you are facing the choices or requirement to understand the different blockchains available in the world. This is a very small subset of the blockchain that is available, but it's already so busy. Right, so we mentioned like Ethereum mainnet, Polygon, Arbitrum, OP, Base, Rolling, Solana, Nearflow, Tezos, XR, RPL. There's so many of them, right? And secondly, when you try to verify your membership, you have to go through our wallet connection page, and that's also a very busy page because we give you many different choices for the different providers. But at the end of the day, you tell us what accounts you have. And that account could be covered the typical traditional wallet. So sometimes that's called externally owned account. And that's basically just a key pair. Like private key is a credential, and the public key is the identity or the wallet address. Right? Then now we have new form of accounts such as the MPC wallet as well as the smart accounts. Smart accounts are contract-based accounts. And for the contract-based accounts, they don't have the signing ability by itself. So it relies on an external signer to do that. So for the token gating purpose, you can always see this struggle. Like a user need to deal with so many different kind of wallets that match to different accounts. Then accounts has different natures. Some accounts can be reusable across multiple chain networks. Some accounts are only dedicated to a given blockchain. So this is the problem we want to solve. Even for read only, it's already a big headache. But now we get into the space to do transactions for the pool user that targeting for many different chains. That's another struggle for sure. And I also mentioned like for your asset, right? You physically have the asset on one chain, and it's not so easy to leverage the same asset on another chain. There's too many technical hurdles and too many security risks and the missteps you could run into. Okay. So how do we solve this problem? I think the whole ecosystem have been really working hard to see what's possible. So I'm going to go through a few research I did recently and give some insights how the different solutions look like. So the first one is a little bit coincidence. So yesterday, the Near Foundation just launched the testnet for the Near chain abstraction. And that was before I put together this slide. So that was a good, timing. And I want to briefly give you an overview of the key components for the Near chain abstraction and help you understand how it works behind the scenes. So let me just open this see what's the best way to do this. Slideshow and click on the link. Yeah. So this is the overall story for the near chain abstraction. Like near will becomes the stitch layer, the coordination layer, and it's being guaranteed by the staking governance. Like they utilize eigenlayer and the near staking to enforce the security of the MPC network. The MPC network have the different adapters to the different blockchains. I think at the Tesla launch, they only support the Ethereum blockchain and the Bitcoin, but other blockchains such as Solana will be coming soon. So that's the overall idea. Then this is a little bit technical side of the story. Remember, for the previous diagram, I'm talking about as a user, a poor user here, right? Then you sort of have to understand these different wallet addresses. So what Near does is create this account abstraction. So basically, you don't need to understand these different blockchain-specific wallet addresses anymore, accounts anymore. So you just say, okay, I grab a Near account from email. So you can sign up, a Near account, which is like a Raymond.Near or James.Near, right? And the Near account by nature is a contract-based account. So you have quite a bit of flexibility to add logic behind the account to deal with some interesting, business use cases. Then this Near account is the root of your identity hierarchy, and Near give you that flexibility to infer or derive other accounts targeting for other blockchain networks. So, for example, say here's Raymond.Near. Then Raymond.Near, we can append that name with some passes such as Ethereum mainnet -wallet1. So that will deterministically give you a wallet address on the EVM side. And since that account being inferred from the root account, so the MPC network actually helps you to manage that key pair. So you kind of defer that responsibility to the MPC network, and you as the account owner itself or any third party, they don't see that private key at all. You never reassemble that private key in your front end or by your local disk. So it's actually sharded inside the MPC network. And upon the transactional behavior, you make a request to the MPC, say, hey, I want to buy some NFT from this Ethereum address. That's where the MPC network works together and validate your credentials, and then produce a signature that's coming from multiple shares to represent the full signature that you can use to make a transaction on the target chain. Right? So that's where the so-called chain signature come into play. So chain signature is just an interesting way to leverage the MPC network, and the MPC network has running nodes that each of them only own a small portion of the share. Then all the shares can be assembled together to form the final signature. So let me see if I can find a diagram showing that assembly process. Let's see if this block have the diagram. Okay, so this explains the Near account because it's a smart contract. So behind the smart contract, you can write different access keys. Some are having full access, some are only have access to select the contracts and the function calls. Let's see. Okay, so this is the illustration of the MPC network that produced the full signature. So this is the different nodes running in the MPC network, and each of them have a different share of the signature. Then finally, all share signature will be joined together to form the final signature you can use to exercise the transaction. So maybe here it's a better diagram. Let me see if there's a better diagram to illustrate that, because I think this idea is pretty critical. 1 second. Yeah, so I think this one is explain that concept better. So here, like say, you as a user, right? Really, as a user, you don't really care the private key or public key stuff. You basically just say, I want to access the transaction. And from the technical perspective, the transaction has to be signed so that you have a stamp on the transaction to attest that's a transaction from you as a user, right? Then how does the near chain signature deal with that? This MPC now running a bunch of nodes, and just think about you divide the private key into multiple shares, and each of them only have the partial knowledge, and they can use that partial knowledge to produce a signature. So that will become the signature part 1, signature part 2, signature part 3. Then join the 3 signatures together, you form a final signature that can be recognized by the Ethereum blockchain or the Target blockchain. So that's how they solve this private key headache, because now the network is managing the private key and managing the signing process, and you as a user, you don't have to memorize that private key and write down that and bury that on a jar somewhere, right? So that's where the near chain abstraction come into play. So I put a few links here, so feel free to check them out. But I want to cover all the solutions here as well. So let's move on to another popular solution called Layer 0. So let's open this link. So this is another picture that shows the coordination between 2 chains. So we're kind of getting a little bit into the cross-chain story, right? Say you have one blockchain here, and you have another blockchain here. So what the Layer 0 guys are doing is introduce this so-called Layer 0 protocol. So the Layer 0 protocol is very much, they have some smart contract deployed to the chains they support. And I believe at this point, Layer 0 it's EVM only, but that could expand to other blockchains. So basically, you can connect your application level smart contracts, such as the token contract. So Layer 0 have this concept called Omni app or Omni token, right? So basically, it's a universal token, and physically they can present on multiple blockchains. And the token contract has been argument to support the Layer 0 protocol. Basically, now you have a agent for your smart contract, and this agent has the ability to send a message across the blockchains. And then the message actually works behind the scenes with the blockchain events, because the blockchain itself does not have outbound connectivity, right? You cannot use a smart contract to talk to a REST API. You cannot talk to a message broker. So what happens in the blockchain is you can emit events. So that's how the messaging works. So basically, when you try to send a message, you basically emit an event, right? And that event going through this endpoint layer and the message library registry layer. So that registry layer is just handling different type of messaging, handling different type of events. So you can register many different type of events you can handle. Then this message library registry will do that routing and delegation, right? So that kind of happens on the on-chain. Then on the off-chain side, this so-called like a decentralized verification network. So think about this as another MPC network, right? So the MPC network have something deal with inbound events. So it's very much like the event listeners. So you kind of watch the specific blockchain event, and for Layer 0, these events are really belongs to the different messages, right? So basically, when you receive an event here, you basically get a message. Then this decentralized verification network can check the security to make sure nobody can cheat and get enough consensus so that they figure out, oh, that message get wired to another target blockchain. So you need to send that message to the other side. And how do you send that message? You basically have to use a so-called like a executor, right? So the executor basically just sign a transaction and submit that transaction to this message library registry. And of course, when you trigger that blockchain transaction, the message arrive on the blockchain, and the message library registry find out which application they need to invoke, which basically say, hey, now I receive a message, and I'm going to call the hook on the Omni application to handle the layer 0 receive. So you have two hooks. One is on the sending side, and one is on the receiving side, right? So basically, now you connect the two blockchain with this message protocol, and it's being governed by this off-chain decentralized network to handle the security and the consensus and the routing and the watching, right? So that's how layer 0 kind of works. So layer 0 not only just give you this point-to-point connection, it also allows you to compose multiple chains, multiple apps into one messaging agreement, right? So that's how they deal with many-to-many composition. So feel free to check out all the technical details here, but I just want to have a quick fly through on the different solutions here. So that's layer 0. Then next one, it's a similar approach called X layer. Let's also quickly look at some of the diagrams here, and you will probably see the similarity, right? So here, again, you have different applications running on the different blockchains, right? Then they have this X API layer, which basically is the event listener to watch all the different blockchain events, and also have the executor that can post transaction to these different blockchains. Then X have this gateway layer. So the gateway is like the adapter talking to the blockchains. So think about you're running different blockchain nodes here. You have nodes for the EVM mainnet. You have a nodes for Avalanche. You have a nodes for Cosmos. You have a nodes for Pocket DAI, right? So these nodes are kind of you're connected to other blockchains. Then the bottom line is very much this MPC network. Again, it says it's MPC, right? So that handles the incoming events, handle the outgoing, messaging to other blockchains. So architecturally, all these solutions are very similar. At the core, you basically have a on-chain, off-chain MPC network, and then you have adapters hooking up with the different blockchains to be that mediation layer. So this is Exa, and they pretty much also use this concept of messaging. So this is a transaction flow, right? Say you have a user try to do a on-chain call, you talk to the SDK, and the SDK try to handle the work on the MPC network layer. You pay the gas fee here, then figure out how to construct a transaction. Then this transaction will use the messaging to be sent to the target chain for execution, right? So the transaction flow is also similar across these different solutions. So one more to showcase here is this called wormhole solution. Again, architecturally, they are all similar. Think about here, like this architecture, right? So source chain side, you have the source contract that you bind the source contract with some protocol layer contract called wormhole contract. So this is very much the same as a layer 0, right? Then you have these transaction events in the logs. This kind of serving as the incoming messages. Then they have this Guardian network. Again, it's another MPC network that runs as a stitch layer, right? Then handles the agreement. Then finally, if they figure out, okay, this event should trigger some actions here and here, then they kind of have this spy layer to understand the agreement here. Then the relay layer will do the real transaction against the different runtime. And of course, the target side, they are also a binding, which kind of verify the proof from this network, and then confidently dispatch the request to the target contract. So the coordination is happening, say, on the source side, you event, then event goes through this off-chain MPC network, then reliably get to the target side. So again, that's a validation. This architecture is most people are going after. Then we recently evaluated another solution called Layer 1X. I think they're still kind of in the bootstrapping phase. So here's a URL you can go check out. So it also uses a similar approach, like say here's blockchain 1, blockchain 2, then each transaction has approved some events. Then what they're trying to differentiate themselves is they introduce a blockchain in a similar way as the Near blockchain. And this blockchain will only handle the coordination across different chains. And the blockchain itself has the ability to deploy the smart contract. So in the in the solutions I kind of illustrate for layer 0 for X for wormhole. So the MPC network does not have a lot of flexibility. It's kind of like a fixed logic for routing, right? It just say message in, message out. You cannot really intercept the message and introduce some business logic in between. And if you're familiar with the messaging protocols, often people want to have the middleware tier or the mediation tier, right? So the mediation tier is the business logic. You can actually intercept the incoming message and decide what you do with that message, right? And then you can conditionally say, hey, instead of strictly routing that message from one chain to another chain, I can check some of the conditions. I can even do a split. For example, I got 1E on blockchain A. I might want to split that 1E into two different blockchains, like B and C, right? So having a smart contract capability adds some flexibility and power to their approach as well. So this is kind of layer 1X architecture. Again, you see the similarity here. So I think that's all the ones I have, but kind of going back to the Climate story, we already built some solution on the LEP protocol, which is also an MPC network. And we solve a few perspectives with that approach. Number one is we solve the onboarding problem. So basically, similar as Near, right? So Near, you use the email as a social choose, and that will give you a studying account. For us, if you are coming from any social login, such as Telegram, Discord, or you can even use your passkey, right? So these social identities will counterfactually or deterministically map to your PKP, which is an MPC wallet. So you don't even have to claim that ahead of time. As long as we know your social identity, you already have that MPC wallet in place. Then from the MPC wallet, we map the MPC wallet address to a smart account on the ERC-4367 for a given blockchain. So you have a smart contract for that target chain already. Okay. So I think that story is similar to what the Near chain abstraction works. It's just two different MPC network and a different security model. And also the protocol at this point only support the ECDSA, which is the Ethereum compatible signing scheme. But technically, they have the flexibility to expand to other bonding curves, such as Solana. And we actually also did some experiment to do this account inference without have a native support from that bonding curve as well, because LEP have this encryption capability that allows the MPC wallet owner to encrypt some data and store that publicly. Then only the MPC wallet can decrypt the data. So that means if we want to use the LEP protocol MPC wallet as a root key, we can infer many other key pairs, right? So we can infer the key pair for Bitcoin. We can infer the key pair for Near. We can infer the key pair for Solana. Then we just store the private key, encrypt it with the PKP itself, and also with some advance in technology like passkey. Passkey also have this blob layer that allows you to store the confidential information to the passkey only owner itself. So there are also pros and cons for the different approach, but I think we start to see some hope in this muddy, messy, multi-chain, cross-chain work. And the Cloudland try to be that assistant layer. We try to minimize the barriers and reduce all these frictions for our users, right? So we give our users a comfort zone, right? Whichever platform you are native with, you are studying with, that's your starting point. Then we incrementally map out these technical passes for you and deterministically give you the presence on the blockchain and resolve this signing issue, resolve this onboarding issue, resolve this gas fee issue, basically make Web3 more pleasant to work with and just extract the best value from this engagement instead of get trapped into all this technical nuance and fall into the security traps. So that's pretty much all the materials I have today. I know it could be really overwhelming and I have to quickly fly through many different things, but I think this is just an invitation for conversations. So if you have similar use cases, you want to talk with us, let's do it.
Yay, thank you so much, Raymond. I'm not sure if we mentioned it before, but if anyone happens to have any questions, feel free to drop them in the chat, or you can raise your hand as well to make any comments. You'll be brought up in the stage, or to ask any questions if you have any. But again, thank you so much, Raymond. We also have the POAP to be distributed, so maybe it is a good time to do that. What do you think?
Yeah, it's always a good idea to share the POAP, and that's your attestation to engage some of the meaningful conversations. Yeah, let's do that. And meanwhile, like if you have any questions, feel free to post to the chat, and I try to address that as much as possible.
Wonderful. Yeah, we do love POAP time. Let's get to it. I see that we have an audience of 109 views on Twitter. So I will mention again that in order to claim the POAP, you need to hop onto our Discord server. You can join by going to our Twitter's bio. You'll see our link tree, and if you click that, you will find then an invite to our Discord server. So you need to do that, join our Discord, and then you claim your POAP here inside of the Discord server. And you can do that by using the / command /POAP claim. You will be able to do this later. If you can't do it right now, it should be available to claim for a month starting today. So again, you use /POAP claim, and today's claim phrase is chain. All lowercase and with no spaces anywhere. Chain. That would be CHAIN. And there's a question for you in the chat, Raymond. Maybe let's get to it, and I'll go with the secret phrase.
Cool. Thanks. So Jens has this question like, what multi-chain, cross-chain solution do you think works best for AI? So we might have to look at that from multiple perspectives. AI can play many different roles in the crypto space. Right? Number one is AI can be the interface. We're talking about this onboarding, transaction execution, and this intelligent routing. So I think AI could be that natural language translator, so that it fully understands the user's intent. Then use the AI capability to invoke the different tools to construct the transaction object and find out the corresponding account for the target invocation. So in that sense, AI can be a interface layer, right? And the secondly, AI can be the infrastructure layer, because, for example, AI is dominated by centralized players, right? And how we meaningfully have the AI to be decentralized so that the contribution of the resources and the consumption of the resources can be meaningfully governed using a decentralized model. So when it comes to the different solutions we are evaluating here, at least I don't see an obvious differentiation from the AI perspective yet. I think all the solutions can work in tandem with AI. Uh, and my take, especially wearing the hat of the user, I think AI can be immediately meaningful to help us understand the intent from the users. And we hide all this sophisticated infrastructure behind the scenes and make the multi-chain, cross-chain really easy. Then over time, if the user engages like trading, and we talk about this cross-chain liquidity management, right? It's all your money, but your money are being, distributed across multiple banks, right? Now you want to buy some stocks here and there. How do you meaningfully move these funds across the different banks and serve for your purpose without being a heavy cost? So I think AI can help you learn that knowledge over time, learning from all the trading patterns from other people and get the market insight. So we can potentially even build like AI agent in the background and kind of watch your accounts and do the tradings for you. So I think the door is open. There are many different opportunities, and having the infrastructure talk to each other and serve the purpose for the user. I think that's something exciting.
Really cool.
Questions?
Thank you.
I bet there are many questions, but maybe it's a little bit overwhelming to list the questions. But feel free to reach out after the meeting.
Yeah, for sure.
So my TLDR is like, one is the multi-chain story. We need to really help the user. It's really hard for the user to manage so many accounts, to form a hierarchy or a graph for the user identity credential. That's critical. Okay. And secondly, it's like have a pseudo blockchain layer or the MPC network that be the coordination tier that glue all the blockchain patterns together and even virtually manage your assets. That's another thing to remove some of the barriers. So I think at least we are seeing some hope.
Indeed. And will we be seeing some of these on Telefriends?
Yeah, so that's a good question too. Like, for example, as I mentioned early on, when we launched Telefans, right? So we only support option, and of course with this multi-chain, cross-chain relay layer, and also the onboarding insurance we have, and the account abstraction. So you can potentially say you start from your Telegram ID, right? And that Telegram ID give you an account that could be universally meaningful to all the blockchains you are working with. So that's for onboarding. And secondly, for the user trading, right? So now you can have the freedom to hop from one chain to another chain. It's a matter of we get the understanding of the user requirement, and we route the traffic to the right tier to do the execution and give you the feedback. So I think this cross-chain, multi-chain solution opens the door for much better user experience on Telefans as well.
Amazing. Reminder, if anyone has any other questions, drop them in the chat. And the second reminder, in order to claim the POAP, if you're in the state chat, you can click the command that's highlighted in blue, click POAP claim, and the secret phrase for today is chain, all lowercase and with no spaces or symbols. That word, chain. Let us know if it's not working for you. Make sure to tag me. I can get you a code for you to claim the POAP as well if you're having any issues with claiming. Amazing.
TV, what's the secret? What's the secret code again?
The secret code is chain.
Oh, I thought
CH.
was cross chain.
No, just chain.
That's a common
CHAIN.
denominator of
I'm trying to make them simple, keep them simple. Trying my best. But with that, awesome. I see some successful claims in the chat. With that, I think that we are ready to wrap things up. So, once more, thank you so much for joining us and presenting Raymond. It's always a pleasure to have you here, and thanks everyone for joining. I want to extend an invitation to our Collab community tomorrow at 3 p.m. Eastern. So I'll share a link with an invitation to that event. You see the Twitter Spaces link in there as well if you'd like to set a reminder on Twitter. And you can also hit that interested button. You'll be notified in here when the event is getting started. So I hope to see you all in there, and thanks so much again for joining. I'll see you guys next time.
Yeah, thank you for joining.
Bye-bye. Have a wonderful Wednesday, everyone. See you tomorrow, hopefully.